So, in the world of brain research, we've got this hidden conflict brewing. It's a real paradox where the very tools we use to protect a patient's privacy might actually be, well, corrupting the science that could one day save their life. So, what do we do about that?
Okay, so let's start with a question that honestly sounds like it's straight out of a sci-fi movie. In this age of big data and open science, could an anonymous MRI scan of your brain actually be enough to figure out who you are?
And the answer? It's a huge, resounding yes. A 2021 study found that with zero privacy measures, facial recognition software could match a person's photo to their high-res MRI with, get this, 97% accuracy. That is staggering. And, it kind of changes the whole game.
So, how on earth did a medical tool, something meant to help us, turn into this potential privacy nightmare? Well, the answer lies in what you could call a perfect storm of three different technologies all coming together at once.
First off, modern scanners give us these incredibly detailed 3D images. They don't just capture the brain, they capture your facial structure in minute detail. Second, to speed up research, these massive data sets are being shared publicly. And third, facial recognition tech, the stuff powered by deep learning, is just getting ridiculously good. Put all that together, and suddenly an unanonymous scan can be linked back to a person, exposing all the sensitive health info that goes with it. Right, so in response to this pretty serious risk, the scientific community developed a solution. It's a process called defacing, and the goal is super simple. Scrub the identity from the scan and keep the patient's data safe. Defacing is basically an automated process. An algorithm takes that 3D head scan and just computationally removes or blurs out the facial features. The nose, eyes, jawline, even the ears sometimes, all to make it impossible to re-identify someone. And not all of these algorithms work the same way. Some use a really simple mask, basically just sticking a digital black box over the face. Others, like an algorithm called quick shear, find a shearing plane and just chop off everything in front of it. And then there are more advanced methods that transplant a totally generic average face onto the scan. The hope there is to create something that looks natural enough that it won't mess with the analysis software. But here's the kicker. Does protecting privacy this way come at a price? And this is it. This is the paradox. In solving the privacy problem, researchers accidentally created a whole new scientific one. The very act of protecting the data might be damaging it. Yeah, don't just take my word for it. This quote from a 2023 study in the Journal of Medical Imaging really puts it bluntly. This fix is not perfect. Even though these algorithms are only supposed to touch the face, they can have these major downstream effects on how we actually analyze the brain itself. And here's what that damage actually looks like. So on the left, you've got analysis software doing its job, correctly mapping out the brain's tissues from the original scan. But on the right, after defacing, that same software just gets confused. It might misclassify tissue, or, in the worst cases, it could digitally remove entire chunks of the brain from the analysis. And even tiny errors, when you multiply them across thousands of scans, can totally compromise major research findings. Okay, so researchers obviously needed to figure this out. They had to quantify this damage. Just how bad is it? And are all of these defacing tools really created equal? Well, the results are pretty startling. This study did a quality check on some of the most popular defacing tools. Now, a type I failure means the tool didn't remove the face. That's bad for privacy. But a type 2 failure, that's the one that's really dangerous for science. It means the tool accidentally removed brain tissue. And I mean, look at quick shear. It removed parts of the brain over half the time. Others weren't perfect either, with pretty high rates of brain removal. In this comparison, only one tool, PyDeface, had a perfect record. So yeah, the choice of tool really, really matters. Okay, this is a really crucial point, so let's break it down. Researchers found that on average, the error you get from a successful defacing is actually smaller than the tiny variations you get just from scanning the same person twice. That sounds great, right? But the problem isn't the average, it's the risk of those catastrophic failures, those outliers where the process goes so wrong it makes a scan scientifically useless. It's a unique and dangerous kind of error that just rescanning someone doesn't introduce. And let's be clear, this isn't just some abstract data problem. These data sets that are being defaced are the bedrock for research into some of the toughest conditions we face: Alzheimer's, MS, brain tumors, neurodevelopmental disorders. Corrupted data could mean delayed progress. It could mean we're risking the integrity of scientific discovery itself.
So all of this leads to a fundamental dilemma, a really tough spot for pretty much every neuroimaging researcher working with human data today. They're just caught in this incredibly delicate balancing act. On one hand, they have an absolute ethical duty to protect their patients' privacy. But on the other hand, they have a duty to produce accurate, reliable science. They have to pick a tool, knowing full well that some fail often, and that their performance can change depending on who's being scanned. There's just no easy answer here.
Which brings us right back to our central conflict. As facial recognition gets smarter and our scientific data sets get bigger, this tension between protecting privacy and ensuring scientific progress is only going to get more intense. The question isn't whether we should pick one over the other. The real question is how we can innovate to do both perfectly. And that's the real challenge ahead.